Okay, so today I'm going to share some of my work on the smart decision making in wind energy production with deep learning. So my name is Min Xia. I'm currently a lecturer in advanced manufacturing at the Department of Engineering. As we all know, wind energy is the energy obtained from the wind. And actually, it is one of the oldest sources that we exploit by human beings. And back to 5000 BC, wind energy propelled boats along the Nile River already. And from some pictures, we can see this is an example of an Egyptian boat, which is 1400 BC. And later, we've invented like windmills to use the wind energy to process food and also pump water. And in 1888, Charles Babbage has invented a windmill that can generate electricity. And because of the advantages of wind energy, it's renewable and clean. So it has been nowadays, there are a lot of wind turbines around us, and it has been the most established and efficient renewable energy source. And actually, if you have a chance to visit Lancaster University, we do have a wind turbine in our university. It's not located inside the campus, but it's quite close. And this wind turbine started operating at the end of November 2012. And the annual energy produced by the wind turbine is about 5 million kilowatts. Yeah, you may not have a good sense of the number of this amount of electricity, but can you guess like how much, in percentage, this would provide the campus electricity consumption? So the result is 15%. So you may be a little bit shocked about the result because this single wind turbine can produce 15% of the entire campus electricity consumption every year. And also it can supply more than 1,500 houses for 1 year. And it can reduce the carbon emissions by several thousand tons. So we can see there are a lot of good advantages of using wind energy. And actually in 2020, the wind energy provide about 16% of the Europe's electricity demand. And the UK is one of the leading countries in the use of wind energy. And we can see UK, it's about 27%. And in the next 5 years, there would be a steady increase in the new installations of wind turbines. And you can see this light green one stands for UK, and the UK would play a major part in this development. And the right-hand side, this figure, you can see this is about the offshore installations. And you can see UK would have a very large amount of offshore installation in the future. Then we know that we are in a year of smart grid, transforming from the traditional passive grid operation. So in the smart grid, so instead of the one-way flow of electricity, so now there are two-way flow of the electricity and the data. As we have a lot of like smart meters and sensors to monitor the usage of the electricity and also the production of the electricity. So we try to feed this information and data to the various stakeholders to optimize the grid and to foresee any potential issues and can react faster when the challenges arise. And it can detect, react, or proact any changes. And in the smart grid or in the flowchart of this generation, transmission, distribution, and power consumption, we have a lot of new challenges. First, because of these renewable energy sources, typically they are very uncertain. For example, the solar energy, it highly depends on the sunshine and the temperature and so on. And for the wind energy, so it depends on the wind and also some other factors. So unlike the traditional fuel-based electricity generation, so you just burn some certain amount of fuel and then you get a certain amount of electricity. So there can be more uncertainty in the energy production. And also the use of the wind turbines. As we know, the wind turbines are contains a lot of rotating machines like the bearings, gearboxes, and generators. So there can be also uncertainty or malfunctions in this machine. So how to effectively monitor these device and make them as available as possible. And also there are more uncertainty in the energy consumption because of the increasing demand of electricity use. And also there are more smart devices and electrical cars. So the pattern of the use of the electricity would change. So if we can predict or to estimate the energy consumption of different time of day, then we can better match the production and the usage. So our focus task here are to develop some data-driven approaches with machine learning to achieve the prediction of the regional wind energy production. So our approach is to use the weather conditions like the wind speed, temperature, humidity, and so on to predict the regional wind energy production. And the second part is to predict the electricity load, which is the consumption based on the season of the year and time of the day and weather conditions and historical electricity usage data and so on. And another part is to achieve effective condition monitoring of the wind turbines to guarantee the reliable production of wind energy. So mainly it's about the fault diagnosis, which is about to detect and classify the specific fault that it happens so that you can directly locate that fault and then do the corresponding maintenance. Another job is to prognosis. I mean, to predict the future failure so that you can make your plan, the maintenance plan in beforehand. So with the minimum system downtime. So before I go to the details, I want to talk a little bit about deep learning and machine learning and AI. I think we've heard about these terms very often nowadays. And actually, artificial intelligence is a broader term or concept. So it has been there for more than 60 years. And then artificial intelligence actually refers to the technique which enables computers to mimic human behaviors. So in the earlier days, so these AI technologies or algorithms are mainly those rule-based programs that can, for example, play chess games and so on. And then in about 1980, so people developed machine learning techniques or some models or algorithms that are not explicitly programmed beforehand, but the model needs to learn or to adjust the parameters from the data you have. So that is what the learning term comes out. So it's not a predefined program do the job, but it needs to learn from the data you observe. And then in recent 10 years, deep learning has been more and more popular. And actually, deep learning is just a set of machine learning, which uses the deep structure of neural network to achieve the tasks. And we've developed a lot of different algorithms like autoencoder, deep Boltzmann machine, convolutional neural network, recurrent neural network, and so on. And these different type of networks has different advantages, and they can achieve like tasks like image recognition, face recognition and so on. In your cell phones, it's already there. And the natural language processing for like machine translation, and also stock market prediction and financial management, drug discovery, speech recognition, robotics, self-driving cars, and so on. So deep learning has achieved a promising and very good result in many areas. Yeah, as I said, so deep learning, it's actually a deep structured learning. So it's not learning something very deep, but it's the structure that is deep that can do the job. So typically it has like for the older neural network, if you have seen this before, so you have input layer, so which intake your data, whatever input you have, image or some data like the temperature or the weather data, and the output would be here in the output layer, and there is a hidden layer in between, and then you have the connections with weights to be adjusted. So this is a typical neural network, and then deep neural network is just deeper structures. But this is not the only structure; it's the fully connected way. And then we have different format of the network that can do different jobs. And then the most promising feature of deep learning is that it in the traditional machine learning. So when we have the input, we need some desired output, then we train this machine learning algorithm. But before that, we need to extract features by hand. It needs a lot of time and also expertise. But the deep learning combines these two parts, and then it achieves this end-to-end learning, which means you have the input and output. The deep learning algorithm can learn this function or this mapping relationship between your input and output directly. So yeah, just a little bit background about machine learning. Hopefully that can be useful. For machine learning, they're typically catered different problems. So first one is classification, which means the decision is from the data to discrete classes. Let's give some example. For example, the spam filtering. So the input is your email, and then your spam filtering feature would now directly predict if it's spam or not. And this label or this output are discrete. We only have two labels, right? So we call it classification. And also for example, this object detection. So from this image, so we would like to detect these cars or trucks or pedestrians, umbrella, and so on. So also these labels are discrete, so we call it a classification problem. And similarly, for example, the weather prediction. So based on the data we collected, and then we want to predict if it's going to be snowy or sunny or rainy tomorrow. So these prediction are discrete labels. So it is also a classification problem. And another main application is for regression, which means the prediction is the numerical value. For instance, the stock market. So the prediction would be a specific index, okay, for the market tomorrow. And if you can do that in a fairly good way, then you'll make a lot of money very soon, right? And then, for example, called the remaining useful life prediction. Remaining useful life for machine is very important because if we can estimate that value, then we know when to stop the machine before it can have some certain severe failure, and we can arrange the maintenance appropriately. So the remaining useful life is also a numerical value or a continuous value. So this would be also a regression problem. So in our case, so we've developed quite a few deep learning methods for the application related to wind energy production. So first one is the wind energy prediction. where we have the input of the height above the ground, which is the height of the wind turbine, and then the wind velocity at different heights we can get from the sensors, and also the temperature, air density, air pressure, and so on. And then the desired output would be the regional wind energy prediction. And this prediction is a numerical value, so it would fall into the category of regression. So basically, so here from the flow chart, you can see here are the observation data from different stations across the region. And then we uh, input these different parameters from different stations, including this height, wind velocity, and so on. Then first, we need to select the useful parameters, because some of them may be not as useful as others. So we need to find some of the correlation between this input and then the output, which is the energy production. Then what we developed is some neural network, deep neural network. And then for this one, because um, uh, uh, the the signal is a kind of a time series, because it's time, its values happen at different time. So we use called a recurrent neural network, which is good for modeling time sequential data. So here we have these time series data, and then we develop this deep learning model. And then we did some modification or improvement of the training mechanism, because we know that when we have the data, we have the model, we need to train the model. Finally, with the trained model, with the historical data, so we can do the prediction for the wind energy. And also we've done similarly for the electricity load prediction, as this is also a very significant part in a grid operation. So here we input the parameters like month, day, time, like weekday or not, or weekend, like holiday or not, like sunrise, sunset time, and weather conditions. This can affect the usage of electricity. And the output is the regional electricity load. And then we can see that using our model, the model is actually quite similar to the previous slide, because this is also sequential data. So it can use a recurrent neural network to do the modeling. And you can see the prediction is kind of quite precise for the next 24 hours, as long as we can have a good input like data. Let's say the weather conditions forecast is kind of reliable, then we can get a very good result. And the other part is about the wind turbine, the condition monitoring, as we've seen before. So there are a lot of rotating machines, like the gearbox, like the main bearings and the generators. So the maintenance of these devices are very expensive, especially wind turbines are usually in remote areas. If it's offshore, then it's even more difficult, because we need to hire ships to go there. So the maintenance would be very expensive. So we wanted to make sure that the machine doesn't fail for some severe failure. And also, if we can predict the remaining useful life of the machine, then we can arrange the maintenance in a best time, and then we can arrange the resources accordingly. So to achieve this online monitoring with the information and communication technologies, like get the data and then process the data and achieve the fault diagnosis and prognosis. So here are some model we've developed, and this is some the experiment we did in-house. So these are some gearbox, and we have different type of faults, and with different severity at different locations. Similarly, this is the bearing fault data we collected, and have different faults at different location, different severity. So we've developed similarly deep learning based approach. but again, classify these faults at different locations and different severity. So yeah, another one is the remaining useful life prediction. As we see that the system degrades, actually at the beginning it's quite steady, and then it degrades very fast. So we try to develop quite a few deep learning method to solve these problems. Yeah, so here's another methodology, another approach that we've developed. Yeah, I don't want to go into too much details. And then the result shows a very good match with the actual remaining useful life of the machine. So yeah, so these are quite a few challenges remaining in the remaining useful life prediction if we wanted to use the data-driven approaches. So first of all, how to use the massive unlabeled data, because in reality, we don't actually know the data, the corresponding condition of the data. We collect a lot of sensory data, but we don't know the actual status of the object. And how can we use different sensors, because nowadays we have different type of sensors we can use. So how can we use them to increase the prediction? And because the system would vary during the working conditions. So how can we cater that? And also how to improve the modeling of the degradation process is still a challenge. So yeah, we've done quite a few work in this part, but still there are a lot of things we can do. Okay, to summarize, so I think what I wanted to emphasize is that deep learning as a promising tool is very powerful in the data-driven solutions in many applications. Specifically here, we can see it's powerful in wind energy prediction, electricity load prediction, wind turbine condition monitoring, and so on. But we still have quite a few challenges to address. First, the lack of data. So because machine learning is data hungry, so we need to collect a lot of data, and then the data quality is another issue we have to face, and also the model uncertainty. So we've make some model using deep learning or machine learning, but because most of the machine learning process is kind of a black box or gray box thing, so how can we make these models more reliable, and also how to explain these data-driven approaches connecting with the physics behind the process is another challenge. All right, so I think that's what I wanted to share today.